In today's lecture, you're going to learn how to detail a model in Inventor. The Inventor version we're using is Inventor 2018, if that helps. A lot of them are very similar though, 2017, so it's okay if you're in a different version of Inventor. This is the model itself. There's the drawing. It is in metric. Okay, so this isn't a standard third angle projection drawing. The model was built correctly in first angle projection. When you go home in first angle projection, bottom is upside down, right's on its side, and front is still there. Okay? That's one of the visual differences when you're in metric part. To generate a detailed drawing out of this thing, you'll want to go ahead and create a new file. The kind you're going to create is a drawing file. When you click on this option, you're going to get a dialog box. It's going to ask you, whoop, guess what it did? It didn't ask me anything. It directly went into ANSI standards and large. So because I did what? File, new, and picked it here. That's why I jumped in here automatically. I don't want this kind of drawing. What I want is, if I go here and get drawing, what do you think it's going to open? The same thing. I want a metric file. So I got to go File, New. Did you see that? File, and just click on the word New instead of picking it from here. Because the default for Inventor is what? Inches, because this is a US-based product. For SolidWorks, the default out of the box is metric. You can, of course, change that default on installation, the same with Inventor, but I have them load the software blank without any modifications. That's why you're getting the default settings. So you have to think, if I'm on somebody else's computer, how do I make sure I start right? You go to File and click on New. That will give you all your options. If you do it the other way, File, and then arrow over and pick drawing, you're going to get the default of whatever that software is, whichever software you're talking about. So we have to click it this way. So the templates we have are in English, metric, and mold design. So that's a nice part about Inventor. To be honest, really what's different about flipping between English and mold design, just like in English picking sheet metal, for example, versus standard, is the toolbars available to you change. That's it. In designing, though, and the detailing, that's a whole different ballgame. Metric really does matter. Okay, units of measurement matter. We know that 44 millimeters is not the same as 44 inches. Okay. So you do have to start correctly. So here's metric, and what we want to start is a detail drawing. There's multiple standards. We discussed those in the past. For our purposes, we're going to stick with ISO. Okay. There's two types. There's ISO DWG and ISO.IDW. We're creating an Inventor detail drawing. Got it? An Inventor. So we pick the I. The ISO DWG is literally like an AutoCAD. So you want to pick ISO IDW, .IDW. Remember the suffixes? IPT is an Inventor part. IPT, PT is for part, I for Inventor. Assembly, IAM, I for Inventor, AM for assembly. When it would drop down to the detail drawing side of the house, the I is for Inventor again, DW for drawing. Okay? So I'm going to pick on ISO. We're going to go with ISO standards. Keep it simple. Yes, all the others exist. It's up to your company, but here we are with ISO. When I go to create, it brings me to a default sense border, and the standard is ISO. That's how you know you have the correct type of file in front of you. That's why if you ever do it the other way and you're just like for example, up here, and you'll always pick the down arrow and pick DWG, your drawing file. When you see that ANSI large and you have a metric drawing, you're in the correct place. If you see ANSI large, you're not. ANSI anything, it has to be ISO. That's your visual cue that you're in the correct or in the wrong place, depending on the type of drawing you're creating. When you're in here, this drawing size is large perhaps, small perhaps, we don't know. Okay? To assess what kind of sheet you have in front of you, you click on Sheet, right mouse button, Edit Sheet. Okay? Now, the name is Sheet. You can change it to whatever you want. Sometimes you'll have multiple sheets. Those of you who are in fluid power class, for example, you'll do an assembly drawing and multiple components. So you might title your sheets based on everything you're doing, like arm, lever, whatever you're working on. In our case, we're not going to play with the name. Size, though, matters. When you look at A3, A4, A2, A1, A0, those are all metric sizes. So if you're in Europe, you'll use metric paper, or somewhere other than the US. Here, we don't use these sizes, we use these. Now, just as a quick review, remember when we're looking at paper, they're close, but no cigar. Okay? They're cousins. Don't ask me why. These standards exist. We just deal with it. Do not argue about it either. Okay? You can, I don't care. When you look at the different sheet sizes, you have these are the A sizes for A1, A2. I don't know why they call everything an A. I am much more accustomed to the A's. They've got B's. They've got everything. For us, we operate on A, B, C, and D. Now remember, we discussed this a long time ago in different classes. 2 A's make a B. Not in education, thank God. 2 B's make a C. 2 C's make a D. So in our case, we're using 8.5 by 11 paper. So we actually pick A. If you pick the wrong size paper, you will get an error message when it wants to print, because our printers only have A size paper in them. Okay? So if you forget to make this change, you will be reminded later on when you try to physically print this. When it doesn't print, then the printer gives you an error message. So that's the first thing to check. Why isn't it printing? Well, did you have the right paper size? Oh, fix it. Okay? So we go with A size. As far as where everything, your title block can be moved around. See that? You're literally play with it if you wanted to. Change the way your orientation of your paper is. See that? In our case, we're going to go with the standard landscape for this particular drawing. Others may lend themselves better to different presentations. Portrait might be a better choice for something else, but for this particular one, we're going to go with landscape. Options, you also have the ability to exclude from count and also exclude from printing. Okay? When you're excluding from count, you might have a sheet 1, sheet 2, sheet 3, sheet 4, sheet 5. Okay? So the sheet 1 will say sheet 1 of 5, sheet 2 of 5, sheet 3 of 5, sheet 4 of 5. When you say exclude from count, it won't include it in that count. Okay, so you might have, let's say, the title page to this thing, because that's what the client would like, or your teacher, whoever your client is. So if you do, for hypothetically speaking, let's say you want to turn in all your details drawings to me in one shot. You're going to send me a PDF of everything, hypothetically speaking. Maybe you're going to do a cover page. Then say, project 1 detail drawings. Got it? Because you can. And if you do that, that's how you do it. You want to exclude that particular sheet from everything. You can also strip it of everything on it and just literally make it a title page so it looks like it was done on a Word document. You can do a lot of things in here. The nice part is if you're putting your portfolio together, your digital portfolio, I would recommend you do something like that. It'll be to your benefit. Even if you piecemeal the detail drawings to me, you can actually PDF the whole set to yourself in the end. So that way you have a digital multi-page document to present, to email to a employer, or to make available online if you wanted to, if you did a online resume, whatever you wanted to do. Got it? So in this case, so there are reasons you want to exclude from count. Exclude from printing is done a lot when we're doing notes. Let's say I have a page of instructions. They're internal instructions for the company. I don't want them printed. They could be my notes that I just put on one page. That's everything under the sun. From notes from when I talk to the client, call the client on such and such day, yada, yada, yada. And you may have that, multiple sheets of it, depending on how much communication you have with your client. And so that's something that you would also exclude from printing. And in that case, you might probably check both of these. In our case, we're not checking anything. Okay? We're leaving that alone. Revision. If this was going to be a revision, you'll include it here. Okay? These are the different things you can do. We're going to hit OK. We're not changing anything. And there we have now the equivalent. It should be. Let me double check. I don't trust myself. Sheet. Okay. A size. Okay, we're good. All right, I did it right. 8.5 by 11. And that's the other way you know it's correct. If you pick a metric one, you'll see very large or odd-looking numbers. So that's your other visual cue that you have the wrong paper size, people. Got it? So you hit OK. Next, the border is decent. It's not that cumbersome. It doesn't really hog up the drawing that badly, so we can just leave it. You do not have the ability to change standards in this lab, but if you are using your own laptop, you can edit this title block completely. Then do whatever you want with it. For today, I won't do that. I'm just going to show you how to do a detailed drawing and be done with it. So the first thing you want to do is go to projected views. See that? Place views is where you want to be. Annotate is where all your dimensioning and bill of materials, parts list as they call it, exists. Okay? Sketch. This sketch is not real. It doesn't actually impact your product. You cannot go and extrude cut it or anything like that. These types of sketches are used in detailed drawings to emphasize certain information, but it's strictly for the detailed drawing. Tools, there's a variety of tools in here. Manage, view, all the usual stuff. So we go back to place views. Your first step is to projected views. So then it's like, oh, wait a minute. I can't do that yet. It says, hey, you first need to identify a base view. Oh, you mean I got to first start here. Okay? You jump over to projected views when you have something to project. You jump over to auxiliary views when you have something to create. And I know your first instinct might be to go here, but you need to appreciate you got to start here. It's all about the base. Back to that song. Section views are awesome in here. I'll show you those later. Details, overlays, there's a lot of neat things you can do. For now, let's bring in our base view. Because that's the drawing that's open, it automatically selected it here for the file. Okay? In reality, if you did not have anything else open, so let me intentionally close this, when you go to base, you'll have to go hunt it down. If you have it open, that's one less thing you got to worry about. So we go hunt down the drawing we want. Mine, I dropped it on the desktop. I did, of course, automatically forget it. There it is. There's the part. Okay? Now, when you have the file, you've selected it, look down here, you can find the file. There's something called project files. We don't have any project files, but you can actually be saving stuff in such a place. So that's something for another day. Right now I've got a file, it's not in a project, I'm just going to go ahead and do a detailed drawing of it. Whoops. I guess because I jumped around, I couldn't find it again. So let me go find it again. And hit, there's also options. You have different ways to show your view. Last active, that's how it was presented. You have master, you have front, different ways you can bring it in. To me, it doesn't matter, just as an FYI. When I hit open, okay, master is how it's going to show it. I have different physical representations. I can show it with hidden lines, which is default, the style. Hidden lines removed, I recommend not using this. And then shaded. For our purposes, we want hidden lines in it, so that's what we're going to leave it at. Okay? The label of the view, view 1, you can always do whatever you want with that, and you can change it later. And then it's got a scale. It's automatically assuming a scale. Since we don't know anything about this part, we're just going to let it drop it in the way it wants to. We're going to hit OK. And there it is. That's the one view it brought in. Not the view I like. Okay. This view does not represent the front of the part. Actually, in this one, the customer is telling us what they want to be the front. They want that to be the front, they want this to be the left side, and they want that to be the top. Which is opposite to how we normally would present this. Typically, this would be the front, which means this is the top. So we're going to change things around. So we're going to pick this view, and we're going to say, let's edit that view. So instead of master, I can say front. See that? Right side, top. I can rotate it any which way I want. See that? I could do it here, but I'm actually messing with it right inside the view, because this will pop up. So based on the way the customer has shown this to me, they want that, of all things, to be the front view, because that's what they're telling me. So I'm going to go with the way the customer wants to present it, but make sure that I do it in first angle projection. They want this to be the front view, that's the front view. They pay the bills, I do what the customer wants. It's not illegal, so I don't care. That is recorded, oh well. So I'm going to hit OK. There's my primary view, my front view, per the customer's expectations. When I project, let's see how this is going to project. Let me do that one more time. Sorry. Project geometry. This is the primary view. I drop it down because that's what's going to be my top view. And I go across to the left because that's going to be my right side view in the world of metric, where my right view is created. So let's see if it did it. And it did. Did a good job. The way I know that it did it right is because these 2 points here are not clearly visible here. That entire left side is shown as hidden lines here. That's how I know it was drawn correctly. It's being presented in the correct orientation. What's the other cue? What settings is this particular drawing done to? ISO standards, yes? What's ISO standards? First angle projection. That's why it's correct. So if your drawing is coming out, yours is good too. You have the left view. So if you chose, you have to make sure when you hit project geometry, you pick the correct view. If you have the left view, See how this is all solid lines? That tells me it's showing the correct side. Okay? So I don't mind which way you show it. This is fine. If you want to show all three, that's okay. These three up here and this one down here. If you wanted to not show this one, that's fine too. I would agree with that statement as well, and it would look like this. Okay? This is correct. This is your front view, this is your left side view, and this is your top view. That's what the customer wants to see. They made a point of pointing at this, so that's fine. Cool? It is represented again in this drawing in what's called first angle projection. Next, detailing. Now, remember when I kept telling you in your model, don't delete your dimensions? Those dimensions were used to build your part, right? So if you look back at the model, every time you did something, you have all these constraints on there, dimensional constraints. See how they're positioned? They're neatly positioned on this view, yes? When I finish this sketch, I haven't done anything, and I go back to my detail drawing. When I go to annotate, okay, I have to open this up, sorry, to show you everything. You have several different tabs. You have dimension, which means I'm going to drop a dimension. Okay. You have chain, you have ordinate, you have baseline. So that I have holes, hole threads, feature notes, text, different types of symbols I might want to drop on my drawing. Then I have something very important. Retrieve model annotations. I would, of course, have this positioned way to the left, but I'm not going to customize this toolbar at all. But be aware where it is in the default settings. It is not at the front where you would think it would be. It's buried somewhere in the middle. This is a very powerful tool because, as you know, your teacher is lazy, and I want you to be lazy too. Why put in dimensions that you've already put in? Okay? There's absolutely no value in wasting time. That you have dimensions here that you added every time you created something. It has actual geometry attached to it. Not just physical geometric constraints, which are the parallel, the center, and all that fun stuff, but constraints of geometry associated with dimensions. You've already done that. So save yourself the time and drop them in. So that's why you pick retrieve model annotations. First thing you got to do, let's say I want to select that view. Boom! It literally dropped everything it can. You can also select the parts. Let's say I want to select specific elements. In this case, it dropped everything in. 3D annotations, we don't have any, to be honest, so we're going to stay out of that for now. See, it's selected view. That's the view I dropped everything in. If I'm okay with it, I can hit apply. Then I pick my next view, apply. And then I pick my next view, if it has anything. There's nothing there. Apply. When I'm done, I X out of it. This is the mess you have to work with, but it's not horrible. These are all the dimensions. What you need to do is clean it up. This is, as I like to say, the reason we're employed is because the software isn't perfect. Yeah, they're looking at AI, integrating it into 3D modeling, but not for this purpose. That's for virtual reality type scenarios where you can actually look at the space you're buying before it's ever built type stuff. There's a lot of neat things we could do with 3D modeling. Detailing, however, is our curse. We will live in it. Now, quick question. What the heck is this comma for? Correct. ISO does not use decimals. They're not missing a zero here. That's a period. So whenever you see a metric drawing, appreciate if you see commas, they're periods. Now, all the annotations are to 2 decimal places. Again, that's a default setting. So you'll want to change that. Okay? When you're looking at changing under Tools, you have Application Options and Document Settings. When you click on Document Settings, your default standard is ISO. Sketching, Drawing, and Sheet, all these little informations, it really doesn't affect what we're talking about. When you go into Application Options, here's where you have everything. When you're looking at the drawing, you're looking at, oh, by the way, here's a beautiful thing. Retrieve all model dimensions and view placement. For drawings, if you turn this on, it's not on as a default setting, but if you're using your own laptop, if you turn that on, anytime you create a detail drawing, you bring your views in, all your dimensions pop in from the model automatically. That's a time saver. Make sure that's active on your personal toys. Okay? They're not active on these because these are just public computers. When you look down here, dimension types, preferences, everything is in here. Line weights, shaded, inventor drawing, non-inventor, how to handle a drawing. Okay? Settings, line weight display settings are here. So if I go into settings, I could change how my line weights appear. Okay? Dimension types. You have different types of dimensions that you can identify. Okay? Display. We jump over to display. Notice that every time I touch something in here, it rearranges these tabs. I actually find that really annoying. I have not spent the time, it's probably a setting to not have it do that, but be aware of that. I leave these computers intentionally neutral. So you end up getting whatever you get when you first load the software. General settings over here are everything, just generic things about your drawing. The username, it's called Design 1. You can have it your name. How it saves, file, information, where the data is pulled from. If you ever wanted to know where the default templates are located, there it is. You're going to open that file, change it, whatever you want. Colors. Let's say you don't like this beige background. You want something else. You can pick whatever you want. We don't care. Display is how everything is displayed. Hardware, the performance, prompts, all these kind of prompts. Drawing, this is where the drawing portion is. Notebook, you're going to have notebooks. Save, oh, come on, seriously? Oh, yeah, it's going to jump all over. Part, what kind of part files? Display, assembly. See how it keeps flipping every time you pick something? That's what it does. Default drawing file type, settings, and you can import AutoCAD related settings or Inventor related settings if you had settings that you like. Okay? So those of you who want to import settings, you're welcome to do so. When you're done editing anything in here, I've changed absolutely nothing, I don't think, while I was in here, correct? Just wanted to show you where everything is. You hit OK, it brings you back here. So when you look at your annotation, you still have what kind of settings on your annotations? How many decimal places? 2. Does metric operate this way? Depends. One client might, another client might not. So when we're thinking about how to change our decimal places, we can do a click on the item, right mouse button. Down here you have new dimension style, you have edit dimension style. See that? I do everything on the screen. Up here, when you had place views, annotate, sketch, tools, you'll notice in tools it doesn't exist. Manage. When you're trying to change the style of your file, including dimension styles, you have styles editor. Okay? When you click on Styles Editor, everything appears. Every type of modification you want to make on style is in here. Balloons. Let's say you want different shapes of a balloon. I don't want it to be round, I want it to be square. Got it? It's all here. Center marks. What kind of center marks? Down to the spacing. See that? Datum, target. What do you want on it? Dimensions. This is where we are. Default, metric, decimal markers, a comma. Please get accustomed to the comma being used as a decimal marker. Okay? Don't insist on changing it over to a period. Please don't. I need you to become accustomed to international standards. Okay? Now, we don't need 2 decimal places, so we're going to wipe that out. Method 2A, save edits. It always wants you to save whatever you do. There's method 1B, 2A, 2B, default millimeters and inches. That's the 3 decimal places. That's when you're going to show the inches inside. Default ISO. Default ISO. Which standard do you think we're in? Did we change anything? Do we make any special accommodations up front? No. I hit save and close. Nothing changed. Which one did I change, guys? I changed default method 1B. The default we're using is ISO. Just plain old ISO. Nothing fancy. When we hit OK, save and close. Now the decimals go away. I understand your first thought will be to pick the first one because it's there. I'm just making sure you're aware that it's the last one. Okay? As an FYI. Because I know you're going to come up to me and say, hey, I changed it. Why is it not changed yet? And I'm going to ask you, did you change default ISO? Your answers are going to be, yes, I did. I'm going to say, did you change default ISO or one of the methods? Aha. Got it? So just so you know. Feature control frames, for those of you in the metrology class where you're doing GD&T. Look familiar, people? There it goes. Everything's in here. Hatch. What kind of hatch pattern? I'm not going to care too much which one you use for our purposes. But in the field, we care because it's a material thing. For us, this is all just basic steel. And ANSI 31 is a steel. It assumes steel. So you have to think about all the different types of materials. If for some reason you ever need one that's a solid material, you can pick solid. I don't know why, but FYI. Okay? You can pick ISO. I would not pick any of these. All right, I'm showing my bias. I'm staying to ANSI 31. Okay, whole tables. Whole table, yeah, save changes. Whole table is when you're generating a table of information. That's very similar to some of the drawings we've had, where you're not actually putting the dimensions on the drawing because it's too much of a mess. So you're creating a table, and each hole has a letter designation, and you got to go to the table to find out what you're doing. There's a couple of reasons to use that. And you could go down the list. Layers, yes, we actually do use layers in Inventor. And in the case of Inventor, everything has its own layer. Literally. It's quite interesting. It's very parceled out. Leaders, you can actually change. General is, you literally change everything. It's all in here. So when you are done, you hit save and close. If you have settings that you want to import, let's say you did it at home, you can go ahead and import settings from wherever you saved them to. Okay? Whatever you want to do. And now this drawing is ready to roll in the sense we've put in the information we want. Now, you're going to see this dimension is here. The mouse moves, and you're going to find out it wants to snap to settings. The settings it's snapping to, ironically, are the default settings assigned here. So when you look at dimensions and you look at default ISO, I only stayed on the first tab, units. I did not show you the other tabs, the alternate units, the display. Now, how many of you who've been in my other classes, this looks ridiculously familiar? Not necessarily this exact picture, but I've told you spacing, the model from the gap between the end of the dimension extension line, see this, to the model, there's a dimension B. If you look at B, it says origin offset 0.00 millimeters. What does that tell you? Yeah, it's going to be right on top of it. So if I look in here, what do you notice? Yeah, it's right on it. Do we like our dimensions to be right on our parts? No. So you're going to instead have a gap of at least 1/8 of an inch. Now, 1/8 of an inch is what in metric land? 0.125 multiplied by, what was that number? I forgot. 25.4. So 3.175, which, by the way, is what this dimension is. Extension A, and the other end says 3/8. We're going to tackle this one at a time. Now look, you have an 1/8 inch gap. See that? You're literally setting the standards on the other end to force you to change. Your next standard change is going to be up here. Dimension A is going to be 1/16 of an inch, which is half of 3.175, so it's 1.5875. Change to 1.59. The distance E, you see distance E? Distance E should be 1/2 inch away from the part printed, 1/2 inch, which in metric would be 0.5 times 25.4, so that's 12.7. Whoops, I just changed the wrong box. Don't worry, it'll tell you. Dimension E is the 12.7. Dimension D is supposed to be 3/8 of an inch, 0.375 times 25.4. So that's 9.525. In dimension C, we don't have gaps because in metric land, your dimension is not in alignment with your dimension line. Your dimension is above it because we're doing ISO standards. So this doesn't matter to us. C is, I think, the size of the arrow or a gap. We don't care about that. Okay? Arrow information is actually up here, the size of the arrow. What kind of arrow do you want? Open. I'll leave open just for fun, just so you see it. Open actually uses up less toner. Okay? For us really, really cheap people, we go with open because it actually does not use as much toner on the print side. Got it? So let me go back in there. So I'm going to leave it at open, but we're not going to print anyways because you're going to generate PDF drawings. Got it? And you're going to email PDFs. One drawing I'll probably have you print so that we could check this stuff, the gaps and whatnot, because it's pretty easy to fix them. So there's all this information. So make a note of that if you want to take a quick picture, or it's in the video. For those of you who don't want to go, looks like 39 minutes into the video, I recommend you just take a picture. Okay, next, text. Everything is set to ISO standards. We leave everything alone. We are not changing anything. Tolerances, we're not using them, so it's okay. Options, arrowhead placement. I mean, you can get pretty detailed here, people. Hence the nature of detailed drawings. Got it? Ordinate dimension, leaders, how do you want them to behave? Everything is in here. Notes and leaders, we're not changing anything, but that's what it looks like. So remember display, right here, the tab called display. This is what you have to fix because the default settings are wrong. Okay? Save and close, they're wrong for this class. I don't care what other classes might ask for. So now, when you pop these out, they're actually going to pop out exactly where they need to be. All you got to do is move your mouse. And it'll naturally want to snap to the correct spot. So you don't have to sit there guessing it. Don't you wish this existed in AutoCAD? It does. It's in your dimension settings. FYI. I showed one of you the other day. So you drop the dimensions in that you can see. You do not drop in dimensions you cannot see. Got it? Now here you see 25. That's 25, and this is set to 24. This is a radius, see that? Some of these things you really can't see them. So that 50 is showing a part that's not there. Okay, so we're going to eliminate that dimension. This is dimensioning to something we can't see, so we eliminate that dimension. This I can't see it, but it's still not clear, so we're going to have to figure out how to deal with that. This is dimensioning to something I can't see, so delete it. Click on delete. Okay, that's dimensioning something I can't see, so I delete it. The product is not that smart. It's not going to do perfect things. So delete the dimensions that are not physically visible in the view that you're in. Okay? Now when you zoom in, you're going to see that this dimension here looks decent. The arrows are here. By style is fine. They can't fit inside, so they won't go inside. So leave it where it is. So there's no good spot for that dimension. This is dimensioning something you can't see, so you delete it from there. If this is spaced correctly, let's find out. Boom, that's a good spot. Sweet spot right there. That's pretty far out, so let's see. Let's double check where that is. That's that spot. Let's see. That's too close. It's too far. Not sure why it's not tagging. Let's check the style editor again. Display. Okay. E, D. Yeah, looks correct. So this I'll only be able to check when I print it to see if it's actually in the right spot. Okay, guys? This guy I might leave there. This is pointing, that's okay. So now that I eliminated the dimensions that I cannot see clearly in these views, now let me pick this view and pick, I forgot where we were, under Annotate and Retrieve Model and Annotations. Notice what it did? It dropped, hit Apply, and then I can X out of it. It dropped the dimensions that I eliminated from the other views, it dropped them in here. Had I, let's do it one more time just for fun. I'm going to pick this other view and retrieve dimensions. You'll notice it tried to drop in one dimension, but nothing else. See how it did not drop in all the other dimensions that have been there? Because they exist in this other view. Okay? Now if I pick this view and say retrieve dimensions, now all of a sudden I see that one dimension that I like. This is the power of this product. If I have to talk about where is this product a beast when it comes to detailing, this is a beast. I love it. It doesn't, it watches out for me to not double dimension. And it doesn't force me to leave a dimension in a view that I don't want it to be in. Okay? Some other software products don't do that. SolidWorks, for example, drives me insane. So, because it does not let you detail the way you need to detail from a logical perspective. Well, where you drop that dimension is where you gotta leave it when you were making your model. Here. What you did here literally translates here. Inventor does not do that. No, I don't work for this company. I don't get any benefits from this company. I'm just telling you my personal opinion as someone who's done the deed. So here we go. We drop some dimensions. Even in this view, this is a very difficult object to notice. I might say we're going to have to dimension that here. Those are the only, that box in the bottom. I don't like dimensioning to a hidden object because I can't see it. Drives me nuts. The other things that are missing, we'll wait on that for a little bit. What else is missing, people? We're missing center lines, right? Center marks. So center marks are right there. All you got to do is pick the object and your center marks appear. So it's pretty straightforward. You will want to extend them out. Some of these dimensions you'll want to pull out to be attached to those end marks instead. If you built it like an arc, I think this thing was built like an arc, this particular object. The top arc, I think there were arcs, so I'm going to pick the center object instead because I'm going to try to get center lines. Let's see if I get, there we go. I'd rather get center lines to be pulled out. So how the objects will be built, how they were built, will define how the center marks appear. If this was built separately of this, which it was, the center mark for that, when you pick the arc, only showed up halfway, because that's what it was. So I had to pick the little circle in the middle so I can get the kind that I want. Escape when you're done putting it in, then you could drag your dimensions, your extension lines out. Because you don't want a dimension inside your part. This dimension is in here like this because that is a metric standard. Get used to it. That's how it dimensions in metric land. Okay, guys? Don't worry about it. That's just how it does it. Now I can go ahead and pick this view and retrieve some dimensions. Hit apply. Takes in everything. X out of it. Now I can drop in some dimensions here. Drag my extension line out. Drag this, that's that half inch, that 50 mark I want to take somewhere else. I can drop this down here. Drag that here. We'll want to drag those, the nodes, those little green nodes. The grips, whatever word you want to use. Drag those out. Okay? Yes, dimensioning is tedious. Takes time. That is what I like to say keeps us employed. Because they haven't figured out how to automate literally this process. Okay? The human element is still here. Drop this dimension in the appropriate spot. This I want to drag out to here. It wants to dimension on that side, which is a little annoying. There we go. That'll look nice. And I will dimension that one object in this view. So I'll pick that view and retrieve dimensions, and it picks the only two dimensions it can drop in there that are not duplicated elsewhere. So I'm going to drag these out. They snap to a standard position. I'm not quite sure. There we go. This guy, I got to pull the center lines out. Drop it to endpoints. You don't want dimensioning inside the part. It can get visually confusing. Okay, now let's see what this looks like. Did we miss anything? The best way to assess that, especially if you already have a drawing you're using, so it's easy for us, just double check all your dimensions. I think it's okay. Nope, I'm missing the diameter. Okay, so the hole and thread feature, we're going to pick that object, and there's our hole. That's a pretty large note. that's good. It's right there. Okay, so diameter 24 through. Diameter 24 through. Diameter 60 at a depth of 12. Okay, so that little hole in the middle is 24, and it goes all the way through. And then you have this large diameter that is 60, and it goes to a depth of 12, which makes sense because that's a depth of 12. Okay. And if I milled it, I might actually use that process as well for machining. I probably will drill the hole and then go and mill down the whole thing. It's good to have it there. So that note's good. What else? Say again? Well, it shows here as a radius of 30. If we were going to do it the other way, you'd actually have to drop an actual dimension in. Diameter 24. And then you would add to the end of it through. And then this will come out as a radius. I would probably put it at the bottom though, because it's got enough clutter at the top. Something like that. Now I would probably say top and bottom, or clarify. Otherwise I'd feel the need to fix it. So I could just say typical, TYP, with a period or without. Okay. Both ways I've seen it. Once it's done, you've got a lot of content down here, designed by Design 1, because that was the name, right? Remember that? When we were working on the different settings. The date, the sheet, 1 of 1. So when we look at all of that, if you wanted to change anything, which you will, because the design by will be your name, not what's on here. When you go up to the main sheet, up here you have drawing resources, default border, you have ISO, field text. See this? Okay, I'm in the middle of something. Hold on. There. When you double click on field text, you can go ahead and change. The author right now is static because it's the author of the computer. Title, if you want to give it a title, has no value. Notice that? If I click on here though, see this little button right here? Again, everything on the sheet's here. See that? You open up the sheet, ISO, double click on field text brings you in here where you see everything. When you go to iProperties, now you can actually change it. Summary, the author can be changed to you. So in my case, I'll throw my name in there. Okay? The title could be, what's this thing called, guys? 4-24 plus 2. What a interesting name. Okay, subject, manager, company. Throw the company in there. Then you go to project, location, part number. So title and part number. See that? You can have the title of the project as something different, and the part number could be something. Part number and title. Why? Because the title of could be project 1, right? Or project 2, detail drawings. You know what I'm saying? Something like that. And then underneath that project, you'll have a part number, in this case, of this part. And then you have another part, and another part. Stock number might be whatever your company calls it in inventory, which could be different from part number. Okay? You work for a company that makes OEM. OEM means that you're making stuff under other people's names. Okay? Sears is not making their tools. A bunch of different suppliers make their tools. Those suppliers have different names, but they follow the same standards, so the final product is stamped with the name Craftsman. to give you an example. Description, what is it? It's a widget. What revision, project, designer, oh, there's designer again. So, you can go change that one more time. Engineer, authority, estimated cost. This is very nice. You can assign a price to every single part, and then you can actually data extract it to find out what is the cost of the whole project. So if you assign a price to each nut, bolt, and thingamajig that you put on your assembly, for example, you literally can generate a parts list with pricing. Price list out of your assembly. Isn't that cool? FYI. Creation date, vendor, web link, anything you want to put in here. Again, part number. Put some part number here. Again, part number here. You can leave everything alone. When you hit apply and you close, everything in here changes. Hit OK to that. Wherever there's project 2, 4-24 plus 1, there's your company name. Designed by, see that? Whatever it can change, it'll change. So you can do iProperties up front. When you click on this piece, right mouse button, iProperties, and jump right into this. Summary. Even if I eliminated author in here, I've got designer in here. Got it? Author and designer could be two different people. I can leave, the title can be project 2. That actually works rather well. Under the project, you have the part number, which is down here. That works rather well. Designer would be your name. Company, if I go back here, company could be your, whatever company name you would like to create for yourself. Like for me, it's always been TIG Enterprises. Don't ask. It's the middle 3 letters of my first name. Hit apply and close, and voila. TIG Inc. Whatever you're, I don't know, whatever you want to call it. Cool? Oh, designed by, lost my name again. So let me go back into iProperties. Did I take my name out? Oh, there's a designer. Designed by. But I took it out probably because I took it out of here. Yeah. All right, I'll throw myself back in there. Hit apply and close. There we go. Cool. Check by. Somebody else checks the drawing. Approved by and date. This is what you'd be turning into me. Assuming this is correct. This is just a conversation. I have to check all the dimensions before I assume to send it to my teacher. Of course. Because I want it to be perfect the first time, because I am that lazy and I don't like double work. When this is done, file, you have the ability to do save as. Save, and save often, I always say. So hit save. And then if I do save as one more time, I have the option to do what? Can I save this as something else? How do I do that? Ah, we discussed that in the other project. You export. Export out as PDF. Same place, hit save, it's done. Now when you jump out here, there's the PDF that you'll end up sending to me. And that's it. Emailing is constantly being done these days. The biggest work is just separating everything out. You want a nice and neatly balanced drawing. You don't want to send the client something that looks like, as one company said it to me when they brought me in to fix their designers, as they phrased it. They're not detailing the drawings right. It looks like 5th grader work, is what was told to me. So I went in there and I realized the designers don't know how to detail. They know how to detail if they hand drew, but they have no clue how to control the software to detail correctly. So I literally I got paid to tell them what I just told you guys today in class. So take this information to heart. It is a critical skill in the field, okay? Because customers need detailed drawings. That's how they live by. They have to approve them, because what is this? Your contract with them, correct? You want the customer to approve this drawing. You build it to this these specifications. They get it, they don't like it, it's their problem. They have to pay for a replacement. You do bad detail drawings, guess what happens? Customer doesn't like it. The part they receive, they're like, well, it was your detail drawing I approved, but your detail drawing looks like, and guess what? Now you have a problem. If you're ethical, you have to sit there and ask yourself, is it our drawing? The customer approved it. The thing that's wrong is not detailed on the drawing. If it's not detailed on the drawing and the customer approved drawing the way it was, you can have an argument over that. Depending on how much money is involved, you or they will lose. Got it? So you gotta always do the best detailed drawing you can. And that's it.